Hi all, welcome to my talk on automated metadata creation. First, a little bit about Astun. So Astun was formed in 2005 by Mike Sont, our managing director, and we are the UK market leader for open source geospatial solutions, including web mapping, enterprise GIS, metadata, and data discoverability. We have an inviolable track record in helping local government, charities, and commercial organizations to enhance their service delivery, and we are also one of this year's Phosphor-G UK national sponsors. I joined Astun just under a year ago, and I work alongside Joe Cook in the data discoverability team. So what is metadata? So my colleague Joe Cook previously covered this in very good detail in a past webinar, so I highly recommend that you keep an eye out on future sessions or watch the recording on YouTube. There is a link to that in the speaker notes. So the way I think of metadata is as the labels in a supermarket. If you want to buy, for example, like a can of dog food and there's no labels whatsoever, you don't know if you're going to end up with like cat food or beer or baked beans, who knows. So in simple terms, metadata is data about data. Another common term that gets presented quite a lot these days is QFAIR. So QFAIR is all about making your data high quality, findable, accessible, interoperable, and reusable. Also, this is best or most easily achieved if your metadata is also QFAIR, and best achieved by using open standards and formats where possible. So what do the letters mean? Q stands to quality, the hyphen is just a hyphen, F stands to findable, A stands to accessible, I for interoperable, and R for reusable. So a little bit about why are we doing this. So we have a need to make it much easier for people to create metadata in bulk for thousands of data sets. So currently we use Crawler, which is the metadata crawler open source plugin for Talend Open Studio. It looks for spatial data in file systems and databases. It then creates a metadata record for each source it discovers and a feature catalog record for vector data sources. We then generate a spreadsheet with a row per record for data owners to complete the manual fields. I also included a link in the speaker notes to a presentation by my colleague Joe Cook on how we do this in more technical detail, if you're interested to see. So to get a compliant metadata record, we need a number of fields. So these are things like the abstract, the bounding box, the date, inspire keywords, lineage, temporal extent, the title, of course. So a number of these are calculated by Crawler. So you can see there's a few left. Then from these ones that are left, there are a number of fields that we normally populate with placeholder text. So there's a number that also get taken away. But as you can see, we are still left with a number of elements that can be quite time consuming for our clients to populate if they have large data holdings. So we're talking thousands of data sets. So for these, we found a way to automate them using Spacey. Spacey is industrial strength open source natural language processing in Python. It's easy to pick up and it's actively developed and used, and it's very well documented. And we also looked at other approaches, but they weren't such a good fit. So with Spacey, we looked at populating these fields. So starting with geographic keywords. This was the trickiest element to handle. Geoparsing, although it's definitely a thing, it's generally not very fine-grained, and we needed a level of detail that was taking that down to UK roads and like settlements and mountains and even postcodes. So for this, we built two custom pipelines, one that uses named entity recognition trained on DOS Open Names dataset, and one that uses pattern recognition for postcodes. So this approach, in our experience, was the best for processing efficiency, and it also runs on a normal laptop, which is a huge benefit. So you don't need any, powerful machines to run it or anything like that. So next we looked at non-geographic keywords, and there are loads of options for this, and we are not very sure yet which approach gives consistently the best results. So we are currently running a few of them in parallel. We are using PyText rank, keybird, and Yaki for inspire keywords and topic categories. Because these are controlled text fields, we are using text classification to pick the keywords and categories that best match the data that we get. And for everything else, for this, we're using the OpenAI API to generate the abstract, the human readable title, and also to pick the most popular results from all the other modules that we calculate. And we also include a confidence score to help our clients prioritize the workload for large data holdings. So how will this work in real life? Well, instead of the clients having to fill the values in a spreadsheet, they simply review these auto-generated values, they correct any glaring errors, and then we use those to create the metadata records for them. So we are starting from a bunch of files in a directory or a database that we scan and process with crawler, which also includes our machine learning pipeline. Then we produce a spreadsheet which is shared with and signed off by the client, which looks something like the one you see on my screen. And finally, once signed off by the client, we use the spreadsheet to update the records in GeoNetwork. So it looks like the one you see on my screen. Thank you.